Imagine nothing. Forget knowledge. Forget time. Forget space. Forget their containers. Imagine beyond the beginning. Imagine after the end. Forget God. Forget nirvana. Forget physics. Imagine a place without a place. A nothing so nothing that it is everything. Imagine nothing outside its nothingness. And yet from it, everything we know, and everything we cannot know, sprung forth. Somewhere between now and then, there began us. Not as anatomically modern humans. Not as Homo sapiens. Not as Homo erectus. Not as Australopithecus africanus. Not as Homo. Not as Hominidae. Not as Pongini. Not as Pongo. Not as Catarini. Not as Theromorpha. Not as Stegocephala. Not as Cyclostoma. Not as Protozoa. Not as single-celled. Not as algae. Not as acids. Not as chemicals. But as interactions. As fluctuations. As quantum murmurs. As disturbances in the nothingness. As coagulations of chance. We were not destined, but we were inevitable as part of this universe, and only this universe. I became aware of my own existence sometime in the early 1990s. I can't remember it, but it must have happened at some point. I went from being a bundle of sensations and images, to a person with arms and legs. A person who lived with other persons. I recognized myself in a mirror. 31 years from then, I still recognize myself in the mirror. But I also see myself in the cosmic microwave background radiation. Or in the characters in the shows I binge on Netflix. Or in the lyrics to Down with the Shine. Or in the words written down in books. I am not these things. They are not me. But somehow, we are, now. You too, are now. You too, are we. Be here. Now. In this space. All riding the wave of generations before. Until we ourselves are generations before. Each of us, as alone as a star, or the center of an atom, drifting in and out of our interactions, as unique as can be. The same as everyone else.
Spacecraft provides spectacular, first-time ever pictures of Earth, blue planet in motion.
Yeah, it's a graphical interface, as you can see. It replaces
Here on Earth,
the
you're in the sky.
Very used to it. Now, basically, it's
Highway
got
menus
menus
and snow,
and
wind chill
of course,
factors,
with the mouse. And you have things like a calculator, the G-spec.
below zero. There are some very
You can
serious
size
questions
and
this morning
move
about the
around.
combat
And so
readiness
we'll
of American
calculator,
forces
for
in the
example.
Persian Gulf.
And
That certainly comes as the
then we can
Pentagon
also go in here and
published
access
the
the
first
secret
look
by
at
double-clicking on
operations
that.
as
You'll
we
see
see.
the icons come up
Bill
for
McLaughlin
the
has more on that from Saudi Arabia. Good morning, Bill.
subdirectories in here.
Good morning, Charles. Secretary Cheney and General
Let's say we
Powell
want to take a
arrived
look
here
at something
yesterday,
like
and we began a
welfare
series of
or
meetings that are
select on
continuing
that.
here
And,
today.
so we select it.
They're spending about
and
half
show
their
the
time
context
with the
of
troops,
spec
another half
ASCII
their
file.
time with
Then we
the
use
Saudi
it in
royal
standard
family,
tools,
with
prompts
Kuwaiti
there.
officials,
And let's see
with
if we access
high-ranking
something
generals.
like command.com,
It's
which
much
is a
more
machine
than
code file.
just to show
And
the
of course,
flag
take a
out
look
here.
at that. Just when
Parts
you
of the
inspect,
morale
you will see the
booster, although
machine code
morale is
for it.
pretty good.
You have a slider
But
bar
what
here
they're
that you can
doing is trying
reposition,
to
take a look,
demonstrate
and see
that
various
after
parts
the
here.
15th
Not
of
very interesting,
January,
but it shows you the idea there. And we'll close this out. Now, if you want to run a program, let's say, for example, we'll bring the calculator back up here. Let's say I want to run, say, Prodigy. Okay, so I'll double-click on that and bring that up to the
come along
top
to a
command
familiar
line.
planet and see it the way alien scientists might on their first flyby.
We would know it's made out of rock and iron.
Prodigy.
Most importantly, we'd know it's covered within the layer of water and gases that indicate the possible presence of life and the types of conditions that would be capable of supporting life on the Earth.
In a sense, Earth the movie is
While
the work of
Microsoft
a
is
visiting
basking in rave
spaceship.
reviews of
Time-lapse
Windows
photography of
3.0,
the
it's
spaceship
also battling with Apple
Galileo,
over
launched
ownership
from
of
the
the
shuttle
graphical user
Atlantis more than
interface,
a
or
year ago.
GUI.
Galileo
The case is
roared
being
in
fought
from
at the San
Venus the other
Francisco
day
Federal
for the first of
Courthouse.
two
And
close
Apple
encounters
claims
with
it
Earth,
licensed the Mac
before
UI to
soaring off to
Microsoft
its final
for the
destination,
original
the
version of the
planet
Windows
Jupiter.
3.0.
Its circuitous
Apple
flight
claims the
path
second
was
version
designed
of
to
Windows
build up
infringed on
momentum
that
for the
agreement
long
in over
journey.
180
Galileo
days.
also photographed
After
the
2 years of
moon,
wrangling,
discovering
those claims
remnants
have now
of
been whittled
volcanic
down to 10.
activity 4 billion years
Unresolved issues
ago,
include the
and
concept of
confirming
bringing an
existence
icon
of an
anywhere on a
impact
screen,
crater
having
1,200
Windows
miles in
open, and
diameter.
being able to
The
move the window on
projectile
and
that
off the
created
screen.
it staggers the imagination.
We're talking about something that probably approached 100 kilometers, 100 miles or so in diameter, basically. So, as they say, it's a big one. It's sort of like a small state coming through space, you know, and hitting.
In both the menu and in the dialogue boxes and the use of 3D
on
buttons.
Earth.
The other nice thing that people are really
A
excited
shrill
about is we got
greeting from the placid-looking planet spinning in the darkness of space. David Dow, CBS News, at the Jet Propulsion Laboratory in Pasadena.
When one thinks about the great distances between the stars, between one galaxy and another, between one cluster of galaxies and another, it prompts the question, how big is the universe? Here we have to make a distinction between the universe and the observable universe. Beginning with the planet Earth, we know it to be part of the solar system. Our sun is a star, much like all the other stars. Stars are gathered together into great swirling whirlpools called galaxies. Our galaxy is called the Milky Way galaxy. Galaxies, in their turn, are gathered into clusters of galaxies. And these clusters stretch out into space as far as we can see. And when we observe distant galaxy clusters, we find that they are all receding away from us. The further off a galaxy cluster, the faster it's receding into the distance. And all this seems to point to the idea. The universe came into existence around 14 billion years ago. All the matter of the universe was gathered together at a point. There was a great explosion, the Big Bang, and everything flew apart. That means we can see only those galaxies for which the light from them could reach us in less than 14 billion years. It takes time for light to get here. Light is fast, it travels at 300,000 kilometers per second, but the distances involved are immense. That's us, okay? And these are the surrounding galaxies. So let's suppose it takes 14 billion years to get from here to where we are. Now that defines the observable universe. We can see everything inside this radius. And beyond the observable universe lies the rest of the universe, presumably. How far does that go on for? Forever. The universe is infinitely big. At least that's what we assume. Why? Why do we assume that? Because we can't imagine what it would be like to come to the edge of the universe. If in our mind's eye we underwent a long-distance journey and we did come to an edge, what would lie beyond the edge? Nothing. A stretch of emptiness, empty space. But wouldn't that empty space be part of the universe? It just has nothing in it. So we wouldn't have come to the end. Some seek to solve the problem by suggesting that our universe might not be alone. There are other universes. Lots of them. Perhaps an infinite number of them. The whole ensemble is called the multiverse. And the idea is the laws of nature are different in all the individual universes. In the vast majority of them, there is no life because one or other of the conditions was not satisfied. But once in a while there comes along a universe which purely by chance happens to have the right set of conditions for the development of life. We, being a form of life ourselves, must of course find ourselves in one of these freak universes. Well, fair enough. That would account for why our universe is life-friendly. That simply raises another problem. How are we ever to prove that there are universes other than our own, and that they are run on different lines? Other universes, by definition, are not part of our universe, and so cannot be contacted. So it could be that the multiverse idea might also lie beyond the realms of science. When thinking about our universe being life-friendly, one can't help wondering whether there might be other forms of life out there. And if there is life, and it's intelligent, how does that affect the status of us humans? Well, as far as our solar system is concerned, the planets circling our sun, there might be some forms of very primitive life. We should have the answer to that quite soon as a result of planned space probes. But not intelligent life. No, if ET exists, it must be on a planet going around some other star, what we call an exoplanet. And there's no shortage of those. Several hundred have been found, and the tally increases weekly. Most of them will not be habitable. But from the law of averages, there must be many, many Earth-like planets out there. Planets where intelligent life could flourish. Which is not to say that it has. So we have time dilation and also length contraction. The mission controller says, your time is running slow. The astronaut says, there's nothing wrong with my time. It's your distances that are squashed up. My journey took half the time because I've gone only half the distance. It all makes perfect sense. Except it doesn't agree with what the mission controller says is going on. Okay, if this is the first time you've come across this sort of thing, then it all seems quite bizarre. It's all been tested out and found to be true. Not with spacecrafts and flying about at speeds close to that of light, but here. High energy physics laboratories like CERN, just outside Geneva. Here we can check out Einstein's theory using subatomic particles hurtling around the particle accelerator at speeds that are indeed very close to that of light. This is the Large Hadron Collider. If you yourself were to travel at the speeds achieved here, you'd live to be 500,000 years old. That's time dilation. As I say, all this sounds very confusing. You know, different people having different ideas about lengths and times. But fortunately, there is something the astronaut and the controllers over there, in fact, all observers can agree on. It comes about like this. We're used to thinking in terms of three-dimensional space. Up, down, sideways, backwards, forwards. So, three axes at right angles, like this. That, coupled with a one-dimensional time, past, future, a separate one-dimensional time. Things changing in three-dimensional space as it moves up the time axis. But what if we're wrong? You know, what if they're not separate and they are joined together, welded together to form a four-dimensional space-time? That's what we call it, space-time. What would we expect to find in this four-dimensional space-time? Well, Whatever it is, it will have to be characterized by a particular point in space, as measured along the 3 spatial axes, together with a particular point in time, as measured along the time axis. In short, we're talking about events.